Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner's burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC. A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Thank you for joining us. This is the Space Nuts Podcast, episode 207. My name is Andrew Dunkley, your host, and with me as always is Professor Fred Watson, Astronomer-at-Large. Hi there, Fred.
Hi, Andrew. How are you going?
I am quite well, sir. And how are you?
Yeah, very. I'm still in one piece. Still, most bits are working. It's all good.
Yeah, well, I'm no longer in isolation. I'm back at work this week, back in the radio station, back in my office. It's about as normal as it can get under the circumstances, but it's almost 3 months since I was actually working from where I used to work, and it feels quite strange. Even right now, because I'm recording the podcast at the radio station, which I have not done since March, I guess. So it's all a little bit weird. And look, I don't mind. I don't like admitting to error because for a start, they're very few when it comes to me. But I had such a terrible time getting back on the radio and working through the desk after 3 months of broadcasting from home. I had to retrain my brain as to how to use the desk and. There's an old thing in radio called second day syndrome. Usually when you're doing your first shift at a new radio station or your first shift ever, you're concentrating so much you don't generally make any mistakes. But then the second day, you're a bit more relaxed and the whole world caves in on you generally. Well, for me this week it was third day syndrome. I was so focused on not having a second day syndrome, I had a third day syndrome. So, oh well, that's life, isn't it? Now, coming up, Fred, we talked about whether or not aliens have visited Earth last week. Not that they visited Earth last week, but that's what we discussed last week. And now, almost becoming a habit of ours, we talk about these things and then a new report pops up that says, oh, well, guess what? So there's a new theory about intelligent life in our galaxy. So we'll be looking into that. There's a project that's being slated for the moon where they're going to possibly send a rover to look for water. There'd be pretty good reasons behind that, and I think I know one of them. And a few questions, one from somebody anonymous. We don't know who this came from, but they were asking about scientific papers. Where do all the papers go? Are they all compiled and put in one data bank, or what happens to all these scientific research papers? That's a really good question. I would suggest they are used to line garbage bins, but I could be wrong about that. We're also going to answer a question from Dan in California, who has simply asked us to discuss the crisis in cosmology. I'm hoping Fred knows what that is. And Mark from Quebec is posing a question of us as to what two questions, if we could ask two questions of aliens, what would they be? Wow, I've actually not put much thought into that, but a couple of things came to mind pretty quickly, so we might go down that road. But I'm sure Fred will have a couple of nice questions for them. But first, Fred, let's go into this interesting and somewhat fascinating publication that came out last weekend through the Astrophysical Journal on the possibility of intelligent life forms existing within our universe, or more specifically within our galaxy. And the suggestion has been that there could be at least 30, which just sort of blows my mind. When I first read it, I thought, I'll double check where this is being published, and I went, okay. maybe not. But it seems to have a little bit of traction.
It's a properly refereed publication, as you said. It's in the Astrophysical Journal, and I know the publication you read about it in, which is not the most reliable in the world, but yeah, they got the story. And of course, it's been picked up in the popular science media. I'm looking at the story. I actually did look at the original paper, but the story, I think the best account of it is in the physics.org website, which is a great news website for physics and astronomy news. So basically what we have here, Andrew, is it's effectively a rehash of the studies on the Drake equation, and basically putting in new values. And you can think about the Drake equation, that equation, of course, that's designed to give an idea based on probabilities of whether there are any communicating extraterrestrial civilizations within range of us. That has, if I remember rightly, 7 parameters in it, and they're all guesses, apart from one, which is we now know that probably all stars have planets, which we didn't know when Frank Drake put this together back in 1960, I think it was. So this is essentially a re-evaluation of the Drake equation using some new statistical techniques. As I said, I did have a look at the paper. There's a lot in it, a lot of assumptions made, of course, as always. To cut to the chase, they come to the conclusion, the authors, who are based actually at the University of Nottingham in the UK, the authors come to the conclusion that there could be at least 30 intelligent civilizations throughout our galaxy. In other words, the sun's home in the universe. It's, the thing is, just to put this in context, probably a year and a half ago, a paper came out from the University of Oxford that said that number is actually 0. Other communicating intelligent life forms are so rare as to be vanishingly small, certainly within our galaxy. And maybe in the distant universe there might be ones, but they're so far away that it doesn't matter. So in a sense, you get what you get what you put into it, and you might say it's the same sort of mantra that we have with computer programs: rubbish in, rubbish out. I'm not saying that these authors have put rubbish in there, but it's you can with this particular kind of study, you can kind of put in what you like, and you get what you like out. There are big uncertainties, of course, even on these values. The scientific paper itself specifies what the uncertainties are in the outcomes. I actually don't have the paper in front of me, but they were large. But the sort of best guess estimate, I think, if I remember rightly, was 36 communicating extraterrestrial civilizations within our galaxy. And it's based on things like how long civilizations last, and that sort of, those things go into it as well.
Okay. But I suppose to come up with a number like that, you do have to make assumptions, but would you call them educated guesses, or would you take it further and say that there is some science behind it?
Yeah.
Is it a reasonable number to assume?
Yeah, I think it is. They've certainly put all the right numbers in, and they've considered things like they've basically taken the age of our sun as being the yardstick, and speculating that that's the 4.6 billion year old solar system. That they say, okay, well, that's the typical length of time it takes to evolve an intelligent civilization, and then they put in parameters as well, like the metallicity content of the sun. Now, metallicity to an astronomer means anything that's not hydrogen or helium. So these are the heavier elements: iron, silicon, carbon, oxygen, all of those, they're actually considered by astronomers to be metals because they're not hydrogen and helium. And so our sun has a particular value of its metal content, and they've basically, stuck in that as well in their theories. They've got various criteria, weak and strong criteria that they apply that actually give you, basically start off with different assumptions about what's happening. Just to give you an example of that, so you know what I'm talking about. Their strong criterion puts in the requirement for a star to have the metal content the same as that of the sun, which is actually quite rich in terms of its other elements, and they're the elements that found their way into the Earth when the Earth was being formed, and they're the things that we regard as our normal environment. So their strong criterion says, okay, put the metal content equal to the sun. And when you do that, you get this 36 active civilizations in the galaxy. Now, that's a small number compared with the 400 or so billion stars in the galaxy, so it's a needle in a haystack job. But they, in a sense, they're coming out with an encouraging answer to, the SETI community, the Search for Extraterrestrial Intelligence community.
Could it sort of, create a catalyst for what to look for going forward in terms of maybe identifying stars with life-bearing planets and potential intelligent life?
That's right. In fact, that's already happening. So, you and I have spoken at length about the kinds of solar systems, the kinds of stars that might have planets that could support life. By far, the commonest type of star in the galaxy is a variety of star that's nothing like the sun. These are red dwarfs. Much fainter than the sun, but they're also where most of the planets have been found, partly because they're easy to find around red dwarfs. But, so you can have a habitable zone in a red dwarf. You could find an Earth-like planet in the habitable zone of a red dwarf. But what we don't know too much about is the effect of the flares on the surface of red dwarfs. They're quite active in the way that the sun's active, but far more so. And so, if you find a strong candidate with an Earth-like planet around a red dwarf, and then realize that this planet's being basked in lethal radiation from the star, that tends to put the odds down a bit. So it gets more exciting when you find, as we were talking about last time, a sun-like star with a planet the size of the Earth in orbit around it at the right distance. That starts to look a lot more promising. And so they're the things that we should be looking for, exactly.
Yeah. I know that a lot of people will be excited by the prospect of possibly 30-plus intelligent civilizations in our galaxy. The downside is that they are suggesting that they're on average 17,000 light years away, which ain't close.
No, it's not. I meant to mention that. Thank you for bringing that up. Exactly. That, on average, that's the distance, 17,000 light years. It's a long way. The 4.3 light years to the nearest star is a long way. So when you're talking about that sort of distance, it's difficult. And it essentially rules out any kind of radio transmitted conversation, because nobody wants to wait 34,000 years to get the answer back if you send a message there.
No, definitely not. If the day comes where we can identify such a planet, it will just add more frustration to the whole thing. We know you're there, but we're relying on a postal service that's going to take 17,000 years to reach you.
Yeah.
Sorry about that. And that's assuming the message doesn't get lost.
Well, there you go. That's a different issue altogether.
Yes, indeed. But it's a fascinating report and one that's certainly gained traction in the popular media. I'm glad to know that it's actually got some substance to it because, as we mentioned at the start, I picked it up in a publication that is of questionable accuracy from time to time. So I'm glad it actually does have some traction. Quite often, some of these outlets only take the sort of the sexy parts of the story and run with that, and the rest of it sort of goes onto the floor, and you never hear about the actual truth. But that's the media in some respects. So you've got to take it all with a grain of salt sometimes. And it answers that great question by Pink Floyd to a certain degree. Is there anybody out there? Possibly so is the answer. Maybe 30 odd.
Which is what the answer was before.
Well, I was hoping it'd be 42. I really was.
No, 36 is near enough.
Close enough. Anyway, we may hear more of this, but it's certainly a very popular area of space science that gets the tongues wagging. You're listening to the Space Nuts podcast with Andrew Dunkley and, of course, Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments, and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, if you'd like to become a premium member of the Space Nuts fraternity, you can do that by visiting our Supercast website. There are all sorts of options there for buying bundles for a small amount of money per month. You can combine Space Nuts with Space Time for $7 a month through Supercast, or you can go the whole hog for $8 a month, Space Nuts, Space Time, and the Dark Sky Conversations podcasts. They're all part of our stable. And if you go to our Supercast website, you can certainly find out more about that, or you might want to sign on through Patreon and become a patron of the Space Nuts podcast. And the other option is to sign on through our carrier, Acast. Now, you can find all that on our website. Everything you need to know about becoming a patron or a supporter. It's not mandatory. As I say every week, you do not have to. We're not telling you to do this. It is purely voluntary. But if you do want to kick the can for a few dollars a month, jump on our website, spacenutspodcast.com, and find out more about it there. Now, Fred, let's move on to our next topic, and that is the possibility of putting a rover on the moon to find water. Now, I think I know why they would want to find water on the moon, but there could be more than one reason for that. But it is a pretty exciting project. Is it something that might happen soon?
Indeed, it's. This has taken me a bit by surprise because I didn't know about this planned mission. But this is work that's going to happen in advance of the first lunar landings that NASA will. When they put humans on the moon, the first woman and the next man on the moon, which is scheduled for 2024. What is being done is a little bit like what was done in the Apollo era. Before the Apollo landings, a number of spacecraft were sent to the moon, basically to land on the surface and check out the conditions. In particular, whether you'd sink into the moon dust if you were a human trying to walk on the moon. So
of course, yeah, because they didn't really know what they were getting themselves into in some respects. And
so now,
even Buzz Aldrin described the surface as walking on talcum powder, very slippery.
Yeah, very slippery.
But thankfully, only an inch or two deep instead of 2 meters.
Yeah, 2 meters would have been tricky. So it's just as well it didn't happen. But of course, we now know much more about the lunar surface than we did in the 1960s, and in particular that there is water in a number of what I might call conditions. There's certainly water ice in some of the deep craters near the South Pole, and that is simply frozen water. But there's also hydrated materials on the moon's surface as well. Rocks that essentially contain water molecules or hydrated molecules. So you're right about the water as a resource. It's not only drinking water, but also it's about rocket fuel, because if you can dissociate the hydrogen and the oxygen using solar power and electrolysis, then you've got the wherewithal to fuel a rocket without actually having it come back to Earth or sending a tanker up there or whatever. So it's an interesting and probably interesting scientifically, but also interesting from the point of view of human exploration of the moon, to find out where the water is, how much of it there is, what it's like, and all the rest of it. So enter a project called Viper, which is a very snaky name there. And Viper, yes, indeed. Viper is an acronym for Volatiles Investigating Polar Exploration Rover. And volatiles basically means water. In fact, it means, in the context that we're hearing it here, we think about the hydrogen. The hydrogen's the volatile aspect of it, and usually detecting hydrogen above a surface tells you that there is probably ice down there. It's one of the ways that we know about the ice moons of the outer planets, for example. So the Volatiles Investigating Polar Exploration Rover, or Viper, is a NASA project, and the idea is that it will go to the south pole of the moon in late 2023. In advance of the first astronauts exploring the moon in the Artemis program. So a really interesting story, because it's all being done, through commercial agencies. There is a NASA initiative which is called the CLPS, which stands for Commercial Lunar Payload Services. I nearly said payroll there, the wrong word. Commercial Lunar Payload Services. That's the initiative that basically brings industry partners in to build and deliver actually to the moon instruments and technology and demonstrators and all of that sort of thing. So one company in particular, whose name is Astrobotic, great name, they essentially are now responsible for the whole delivery of Viper to the moon and its work there, manufacturing it and all the rest of it. So they must be very happy about this high-profile project. Viper's it's quite big, actually. It's almost half a ton, and will work for 100 days. That's the idea, over several kilometres around the South Pole region. basically looking at various soil environments. That's as the brief mentions. The even more interesting part of this, though, Andrew, is that it has 4 instruments on board which will be looking for water. I don't know the details of them. One of them is certainly a drill that will drill into the surface to extract the rock material. But what they're doing is they're going to send 3 of these instruments in early versions to the moon as soon as next year, just in the form of landers. So there'll be, once again, the CLPS, the Commercial Lunar Payload Services Initiative. They're going to send some of these instruments to the moon, land them on the surface, try them out to see how they perform and whether they actually work. Then that allows the scientists to refine them and get them into good order in order to be sent to the moon in advance of the moon landing. The great thing about the moon is it's right next door. It's not like sending instruments to Saturn or something like that, where you've got a 10-year journey. So you can do this. You can send things to the moon, check them out, and then in real time modify what you're building on the final rover. And that's what's going to happen. It's a really exciting story. I like a comment by Thomas Zurbuchen, who is NASA's Associate Administrator for Science. He says, "We're doing something that's never been done before, testing the instruments on the moon as the rover is being developed." You can't do that with Mars, for example. So Viper and the many payloads we will send to the lunar surface in the next few years are going to help us realize the moon's vast scientific potential. So great stuff.
Yes, indeed. And as you and I have discussed, the moon will be a very important platform for missions to Mars. And as we've mentioned today and many times before, the water on the moon could well be a source of rocket fuel. So ultimately, they're going to have to build.
Experiences are what people love the most about travel. That's why they love Viator. They have over 300,000 bookable experiences and something for everyone. Plus, their travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. Download the Viator app now and use code Viator10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Fall. It means there's a crisp chill in the air. It's time to gather wood for the season's first fire, and the leaves are piling up outside. But along the coast of South Carolina, fall is kind of like summer, only cooler. Fires are simply for roasting oysters, and the only raking you might do is in a sand trap of one of our many challenging golf courses. Tap now to discover the joys of fall on the coast of South Carolina, or visit fallinsc.com.
Facilities on the moon to convert that water into fuel. So they're going to have to probably colonize, by the sound of it, or at least have some kind of livable facility.
Yeah, so that's certainly, I wouldn't call it colonization, Andrew, but certainly within NASA's brief is permanent occupancy of the moon, in the same way that there is permanent occupancy of the International Space Station. There's always somebody there. And that's what NASA envisages for the moon. It may well be. So the Artemis program, which you and I haven't really talked about, is a multifaceted NASA venture. One of the important components of it is something called the Lunar Gateway. And that's basically a mini International Space Station in orbit around the moon. It's nowhere near as big as the International Space Station, but it's got similar features, including a fairly large, I think there are 2 of them actually, habitation modules. These are where people can live for relatively short periods, not permanently as we've got with the International Space Station, but you can, it's a staging post basically. It's a place where there can be resources managed there. So it may well be, you could imagine that what you do if you're talking about fueling Mars spacecraft is you lift the rocket fuel that you've mined from the moon's surface up to something like the Gateway space station, and that's where where you fuel up your Mars spacecraft for the longer journey. It's interesting to kind of envisage what things might be like in 20 years' time. Hope we'll be talking about it as well.
Look, it's so very exciting. One of the questions that comes to mind about occupying the moon is how long could you stay there before your body deteriorated to the point where coming back to Earth could actually be dangerous? That's one thing I wonder about, because it's low G, muscle wastage. We've seen in the past where long-term time in space has caused astronauts to come back cosmonauts more specifically, have come back in a weakened state. So you'd have to put a time limit on your exposure to those kinds of environments, wouldn't you?
Yeah, I think that particular one you can deal with exercise, and they certainly do that on the International Space Station with several hours a day of exercise. And the standard duration of what they call an expedition on the space station is 6 months. So that's probably okay. But what's a bigger problem is the radiation exposure that you get on the moon's surface, because
always forget that one.
Yeah,
yes.
No protection, no magnetic field, no atmosphere. So you got the sun's radiation in all its forms is beating down on the lunar surface. So you've really got to think about putting your astronauts underground, or at least shielding them to as high degree as possible. So I think that might be the limiting factor on the length of a mission.
Maybe put a lid on a crater. That might work.
Well, in fact, people have talked about there are lava tubes on the moon, as there are here on Earth, and certainly people have talked about getting into those tunnels where there's probably a bit more protection from the radiation.
No, we will watch with interest. But the rover project, Viper, sounds like one giant leap forward for humankind in making our next step beyond the planet. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
0G, and I feel fine.
Space Nuts.
A shout out, as always, to our social media followers, whether you follow the Space Nuts podcast on Facebook or whether you're a member of the Space Nuts podcast group, where you can all get together and talk to each other. That group just grows in leaps and bounds. You can also subscribe to the podcast through YouTube or your favorite podcast distributor, Apple Podcasts, Google Podcasts, Podbean. The list is long, iHeartRadio, etc. We're also on Instagram and Twitter, so just do a bit of a search for Space Nuts through your favourite platform, and make sure you follow us that way as well. Now, Fred, we've got some questions to answer this week. One that's come from an anonymous source, but one that you did want to tackle. And it's all about where do all the papers go? Hey, guys, I just discovered your podcast this week and I've already sunk roughly 12 hours into it. Absolutely loving it. Excellent topics, and the delivery keeps me captivated. We'll slow down a bit in that case. I was just wondering about all these papers that get published. How does one get their hands on them? Is there some sort of central hub they're all uploaded to, or do we need to already know about them and search them out? Thanks. That is a good question.
It is a great question. And
not something that's ever crossed my mind, but you hear about them all the time in the news. A new paper's been released that says there are at least 30 alien civilizations living in our galaxy. Exactly. Where do they go?
So traditionally, of course, they were literally papers published in journals, and most university departments of astronomy and observatories had libraries where these journals were assembled. And if you wanted to read somebody's paper, you had to go and look at it physically. But now, of course, they're all electronically online. We're in a totally different world from when I started as a researcher. But it's still a relatively complex question. So in astronomy, there are several different journals. They still exist as journals, even though I don't know how many of them still print things. They're actually mostly online. But the main ones for astronomers are in the United States, the Astrophysical Journal and the Astronomical Journal. In Europe, it's Astronomy and Astrophysics. In the UK, it's the monthly notices of the Royal Astronomical Society. And then in different countries have different journals. We in Australia have the publications of the Astronomical Society of Australia, PASA. But there are other ones, many other ones. Icarus is a planetary journal. The publications of the Astronomical Society of the Pacific, PASP. There are dozens and dozens of these. And of course, really key papers go not just in the astronomy journals, but in the major science journals, of which I guess the two most important are Nature in the UK and Science in the USA. However, you don't have to go hunting all these different journals if you want to sort of find out what's going on, because there is a repository of papers. People tend these days to upload their papers once they should wait till they're accepted and peer reviewed, but sometimes they do it in advance of that. They upload them to a site which is called the archive site. So it's archive, but the CH in the middle is an X, because that's what the Greek chi is. So it looks like ARXIV, and that's the archive site. And if you do a search on that, that will tell you it's operated through universities. But if you do a search, just look for archive. Then you're faced with every astronomical paper that's kind of coming out, and there are thousands of them a week. So it would help if you knew, if you were going to have a look, who the author was for whatever it is you're wanting to look for, or what the topic is, because you can put those in the archive search engine. So it's fairly daunting, and you often will find you'll go to a paper and it's full of the technical terms, and that's what it should be, because it's this is leading edge research. What often makes it more palatable for everyday readers, and that includes people in the media and commentators like you and I, Andrew, is the press releases that are often issued by universities when a particularly significant result comes out. But once again, the problem is searching for them.
Yes, well, it's good to know there is some central process that puts them all together, not maybe every single one all in one place, but it sounds like there are collectives of them and they are accessible. So you just got to know what you're looking for and do some searching. But Science, Nature and Archive sound like three very good options. You got any in those, Fred? Any papers?
Yes, I do. Mainly because of being part of some big projects that I've been involved with, in particular the RAVE project, the radial velocity experiment. That produced well over 100 papers. And because I was in charge of the observations and actually gathering the data, I very kindly get to be an author on many of those, usually at the end, because W is somewhere near the end of the alphabet and then often in alphabetical order. So that's the recent ones are certainly because of those big surveys. But yeah, I had papers in the monthly notices of the Royal Astronomical Society, Astronomical Journal, Astrophysical Journal, and I think one in Nature. I think I've only got my name on one Nature paper, and it was back in 1978 or something like that.
That's fine, Fred. Once is good enough, in my opinion. I've only ever won one golf championship, but it's they can't take it away from me.
That's right. Yeah.
And there are advantages to being further down the alphabet. My surname starts with D, and that always put me at the front of the line for the school dentist. So I always felt like the guinea pig. But anyway, I think. Sorry.
By the time the dentist got to W, they'd given up, which is why I'm still paying the price of bad school dentistry.
Very, very possible. Thanks to whoever sent that question in, because it sort of was a bit of an eye-opener for a lot of people, I expect. Let's move on to our next question. It's an audio question. This one comes from Dan in California.
Hi, this is Dan from California. I have a question about the crisis in cosmology. Could you explain to us exactly what that is and why all of a sudden it's becoming more of a topic? Love the show. Thanks.
Okay. Thank you, Dan. The crisis in cosmology, Fred. Is there a crisis in cosmology?
Yes, in a sense there is, because it's certainly in the media. You Google crisis in cosmology and you'll find plenty of stuff on it. But look, I've been around long enough, Andrew, as you just heard about papers published in the 70s, to know that the current crisis is nothing like what it was 50 years ago, when the absolute fundamentals of the universe were really not well known. And what this all centers around is the Hubble constant. And the Hubble constant is basically the rate of expansion of the universe. And it's constant at any given time, but it changes over time. Now, back in the 70s, the problem was finding what the constant was now. It didn't worry about the time in the past. We needed to know what the Hubble constant is at the present time. And there were two camps of scientists, and their values for the Hubble constant differed by 100%. Let me tell you that the Hubble constant is usually quoted in units of kilometers per second per megaparsec. So kilometers per second is a speed, and that's the speed of recession of galaxies. And a megaparsec is a million parsecs. A parsec is the unit used by astronomers. It's rather more than 3 light years. So a megaparsec is, I think, about 3.2 million light years. And what that's saying is, the further out into space you look, the faster the galaxies are going away. And that's just a property of the expansion of the universe. But that's what this constant says. So when I was a lad, a young astronomer, the two different camps, one group were favoring a value of the Hubble constant of around 50 kilometers per second per megaparsec, and the other was around 100 kilometers per second per megaparsec. De Vaucouleurs and Sandage are the two names that come to mind in connection with those, in the reverse order of what I've just told you. De Vaucouleurs was in favor of the higher value. But now, so one of the reasons why the Hubble telescope was launched was to sort this out, because you can measure the Hubble constant by looking at what we call standard candles. And a standard candle is just something whose brightness whose intrinsic brightness and so you can essentially measure how far away it is very accurately. And the standard candles that were used by the Hubble telescope were Cepheid variable stars, which we know about having a standard brightness, and that closed down the answer, increased the accuracy. And in fact, what was curious was what came out of that work was that the Hubble constant is basically the average of the two earlier values that we had. So some people saying 50, some people saying 100. Actually, it was 75. It's exactly halfway between. And that's still about the standard answer. And it comes from not just these variable stars, but it comes also from looking at supernova explosions, stars which blow up and achieve a standard brightness at their peak. It comes from a process called gravitational lensing, and the way we see distant quasars lensed by the gravitation of intervening galaxies. So all that supports a value which is, it's about 73 to 74 kilometers per second per megaparsec. But the problem is that, and that's all good. That's one side of the argument. Where the crisis comes is when you study the cosmic microwave background radiation, the flash of the Big Bang, because we can see those ripples in that flash of the Big Bang that tell us about the way the universe looked then. And you can actually deduce from that what today's Hubble constant is, and you get a different answer, 67.4 kilometers per second per megaparsec. And that is outside the experimental errors. And so what it suggests is that there is something wrong with our standard model of the universe, some aspect of it that is not working. And that is the crisis in cosmology. But as I said, compared with what the crisis was like back in the 70s, it's nothing. That's good agree.
Interesting. When you do a Google search under crisis in cosmology, you get 3,250,000 results.
There you go.
So, yes, it's not a very common topic, really, in the scheme of things. But thank you, Dan, for your question. Hopefully we've managed to not resolve the crisis in cosmology, but at least resolve your wondering of it. Let's move on to our next question, Fred. This is Mark in Quebec. He's got an observation about something we discussed last week in terms of whether or not alien civilizations have visited Earth, but then he follows it up with interesting questions or asking questions. We'll get to that in a tick.
Hi, Fred and Andrew. My name is Mark. I'm recording from Sherbrooke in the province of Quebec in Canada. I really, really do like and love your podcast, but especially the last one when you talked about the possibility that alien civilization visited us. Well, I just wanted to point out the fact that, considering the level of technology required to travel to our solar system and even more in our galaxy, why would they spend so much time and energy to get to us? To get what exactly? Plastic, polluted seawater? I mean, what could they find here that they couldn't not find elsewhere? I mean, if they can get to us, they probably already found numerous other civilizations in their galaxy neighborhood, don't you think? Okay, now, Fred and Andrew, I would still like to know about you. Let's say you have the chance to meet real aliens and you can each ask them 2 questions. What would you ask them? Thank you.
Oh, okay. Wow. Thanks, Mark. Putting us on the spot a bit. Actually, one thing you said, what would they find here that they wouldn't find anywhere else? They'd find us, is my answer to that particular angle on aliens visiting our planet. I think that's why they would want to come here. They wouldn't come here to, do anything else, I wouldn't imagine, unless they wanted to take it all. But they'd find us, wouldn't they, Fred? That would be a good reason.
If we're still around then. Look, exploration of the universe, I guess, is the answer. It's what Enrico Fermi postulated in his Fermi paradox. He said that if civilizations have the wherewithal to travel about the universe, they will do. Even if they're just kind of randomly looking at planets to catalogue what they're like close up, that might still bring them here. So who's going to go first, Andrew, about what we'd ask?
Well, look, I'm going to give the lame question, so I'll go first because yours will be much more astute. But I did put a bit of thought into it, and I think the first question I would want to ask them is, how were you created? How do you come to be? Which would also angle me into the God question. So I would sort of, firstly, how did you evolve? How did you become what you are? Why do you exist? What were the circumstances? How did you develop as a species? And do you believe in God, by the way? I mean, we do, but, in general terms, that would be probably one of the first things, a question without notice, that I would want an answer to. How did you come to be what you are? I would really want to know that. I would also want to know, and I would ask the question straight out, is your civilization successful? And I ask that because I know and we all know of the troubles we face here on Earth with each other, the disputes over territory, the disputes over resources, the constant fighting over borders, the ideology that gets in the way of humanity. I would want to know if they have similar issues in their home world. Do they have the same kinds of civil crises that we have been facing for thousands of years, and what we could learn from each other as a consequence of that. If they did have a successful civilization, what could we learn that might actually make our lives better, or vice versa? Maybe they've got troubles that we can resolve. Those are a couple of areas that I would definitely want to focus on and learn more about from them. Those are just questions off the top of my head, probably more journalistic than intelligent. But those are a couple of things I'd want to know. Plus, I got to throw in a third one. What are you currently paying for petrol? Because we pay way too much here. How did you afford to get here? Because petrol's not cheap.
To which their answer would be, what's petrol?
Probably. Or gas, if for you North Americans. What are you currently paying for gas?
Yeah, gas.
Those two questions about how they were created and, is their civilization a success would be my two off-the-cuff questions. Fred, over to you.
I think they're really profound, Andrew. I think you're underselling yourself because they're
science fiction.
Yeah, science fiction writer. That's right. And I suppose in my heart of hearts, but your first one will be similar to what I'd like to know. Is sort of what's it all about and what are we missing? But to come back to just to focus on two questions. The first one would be, so what about this crisis in cosmology? What's the answer there?
I should have known you'd go there. I can understand that, Fred, because from your point of view, you would want to see what they have learned about the universe.
You want to
see if there's some compare notes.
Yeah, and in fact, my second one would be along the same lines. How did you get here? Come on, what's the secret of your flying saucers or whatever brought you here? I would
definitely be flying saucers, Fred. No doubt.
Yeah, but I'd like to know how they work and that sort of stuff.
Yeah.
But yes, anybody who can come along and tell me what the universe is for, I will be very interested to hear the answer.
I suspect any intelligent species out there, the 30 of them in our galaxy, probably don't know the answer to that either.
No, they probably don't. They'd be in the same boat as we are. It's really, I think questions like this are really good to ask because they kind of focus you on what you really want to know about and what are the things that really in a way trouble us in terms of our understanding of who and what we are and where we fit into the grand scheme of things. So I hope they turn up, and I hope they turn up soon because I want to know the answers to these questions very quickly.
I dare say the question list would go beyond two. Maybe the Space Nuts podcast group on Facebook can throw that one into the mix and have a chat about it, because I reckon that would be a very long topic on the many topics that are discussed by the group. But if you're not a member of the Space Nuts podcast group, you ought to join because they do have a lot of fun. Fred and I tend to keep out of it, but because it's all for you. But occasionally we'll chime in with a comment or two. But thank you so much for that question, Mark, because it is really one that gets the brain going, and I do enjoy those kinds of conversations, as does Fred. That's where we're going to have to leave it. Fred, thank you so much, sir.
It's a great pleasure, Andrew. It's been a very good morning's work. And thank you for your time and your company. And thanks to everybody who listens to us. It's always great to know that there are people out there. See you soon.
Okay, thanks, Fred. Fred Watson, Astronomer-at-Large, the key member of the Space Nuts podcast team. One more thing before I go, and don't forget to visit our website. We've got a new URL. It's called spacenutspodcast.com, and we're still building it, but it's sort of reaching a stage where it's effective now. So on the homepage, you'll be able to listen into all our episodes down the list. But across the top, there are little tabs. We have a blog. There's a bit of information about our background. There's the Astronomy Daily news page that we have, where we just keep adding all the stuff that's coming out through journals, a lot of them, and papers. And you can subscribe to the website. There's even a tab there where you can buy some books, apparently, I don't know what kind of books they are, but they are there. And the Space Nuts shop is up there as well. So spacenutspodcast.com. Visit us soon. In the meantime, stay well, and we will catch you on the next edition of the Space Nuts Podcast.
Space Nuts. You've been listening to the Space Nuts Podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.